All right, yesterday I introduced the three different forms for quadratic functions. Today I want to focus on vertex form. So vertex form is again is f of x equals a times x minus h, that quantity squared, plus k. We call it vertex form because hk is our vertex. And the axis of symmetry is always going to be x equals h. So what I want you to know here is that how does each part, the a, the h, and the k, how does that affect the parabola, the graph? What type of transformations occur from the parent function y equals x squared? So let's take a look. The a value, it gives you, if it's a negative number, then you know there's a reflection over the x-axis. So if the a value is negative, you know it's reflected over the x-axis, which means the parabola opens down. If the a value is positive, then it opens up. The next thing the a value tells us is if the absolute value is greater than 1, then we know it's a vertical stretch, and we know the parabola is going to get skinnier, right? It gets stretched vertically. If that a value, the absolute value, is between 0 and 1, then it's a vertical compression, and that means that parabola is going to become fatter than the parent graph, or wider, another way of saying it. The h value is the horizontal translation. So if h is 7, that means the parabola is going to move, every point of the parabola moves right 7 units. If h is negative 3, that means every point on the parabola moves left 3 units. And again, we got to remember the formula here, right, where it's, I have a typo here. There shouldn't be 2 equal signs here. That's a typo. You should have, I lost my train of thought, sorry. So the formula, the h value, it's x minus h. So when we see the equation, we know the h value is always opposite whatever sign you see. So if it says plus 7, that means that h is actually negative 7. If it says x minus 3, then we know h is actually positive 3. And then the k value is the number outside of the parentheses, right, outside of the x minus h squared. And then that value tells you if it translates up so many units or down so many units. And that whatever sign they give you with the k value, that's the sign. So if it says minus 7, that means you're going to go down 7. If it says plus 3, you're going to go up 3 for the k value. So let's look at some of these graphs and Desmos. So first off, the red parabola is the parent function. It's the most basic function. It's y equals x squared. What I want you to look at is the blue ones I've written in vertex form. So this first one, y equals negative 1 times x minus 4 squared. So think to yourself, what's the a value? What's the h value? What's the k value? All right. So a is negative 1. H is positive 4. And I don't see a number out here, so k is actually 0. All right, so what should the vertex be? The vertex is hk, so it should be 4, comma 0. The a value is negative 1, so we know it should open down. Now look at our blue parabola. The vertex is at 4, 0, and it opens down. And it has no stretch or compression. It actually has exact same curvature, if you will, as the original parent graph, except that it opens down. So the parent graph, you go over 1, it goes up 1, right? You go over 2, it goes up 1, 2, 3, 4. If you go over 3, it goes up 9. Well, same thing here. We go over 1, we go down 1. We go over 2, we go down 4. We go over 3, it goes down 9. Okay, so there's no stretch, there's no compression there. All right, for the next two, once you figure out what a, h, and k are. All right, in this middle graph, we have the equation y equals 2 times x plus 3 squared. All right, so a value is 2. H value is negative 3. And k is 0. So what do we expect our vertex to be at? HK. So it's going to be negative 3, 0. Negative 3, comma, 0. Is that where it's at? Yes, it is. And then we expect the parabola to open up because the a value is positive. What was the 2 due to the parabola? It does a vertical dilation. It's a stretch. So again, the parent graph, we go over 1, we only go up 1. But look at this. We go over 1, we go up 1, 2. Twice as much. If I go over 2, I usually go up 4. Look what happens here on the blue graph. I go over 1, 2. It goes up 1, 2, 3, 4, 5, 6, 7, 8. Goes up twice as fast. Okay. Also, the other side of the parabola would be the same situation there. All right. What you get for the next one here? This is y equals negative 2 times x plus 3 squared. So a in this case is negative 2. H is negative 3. And k is 0. So this one's almost the same as the middle one. What did I do differently? I changed the a value to negative 2. Look how it affects the graph. The graph reflects over the x-axis, so the parabola opens down. It has the same vertex at negative 3 is 0, but it's opening down. It's also still stretched, right? It's still stretched, but it's been flipped over the x-axis, so it opens down. All right, let's look at our next 3 examples here. So first one here on the left, we have y equals negative sign, which is negative 1, times x plus 3 squared plus 8. So our a value is negative 1. Our h value is negative 3. Our k value is positive 8. So name that vertex, negative 3, comma 8. There it is. Negative 3, comma 8. What does the negative 1 do? It reflects it over the x-axis. So this parabola is opening down, but it has no stretch, no compression. Look at our middle graph now. It's y equals negative 1 times x minus 2 squared plus 8. So a is negative 1. Our h value is positive 2. And our k value is positive 8. So what do we expect the vertex to be at? H comma k, 2 comma 8. There it is. 2 comma 8. There's our vertex. All right. Does this one have a stretch or compression? Nope. But the a value is negative, so reflected over the x-axis, and so it opens down. Look at our last one here on the far right. We have a, it's going to be y equals negative 4 times x minus 6 squared plus 16. So a value this time is negative 4. H is positive 6. And k is 16 positive. So what hk is 6, 16. Look at that. There is our vertex at 6, 16. Now this one, the negative sign tells us it reflects over the x-axis, so it opens down. And is this one stretched or compressed? Stretched, big time, right? So usually you go over 1, up 1. This one you go over 1, you're going to go down 4. Usually you go over 2, you go up 4. This one you're going to go over 2, and you're going to go down 16, because 4 times negative 4 is negative 16. So you go down 16 from there. All right. If you go over 3, usually you go up 9. On this one, if you're going over 3, you go down 36 units. Okay, so it goes down very fast. That's why it's a vertical dilation and it's stretched. All right, let's look at 3 more graphs. This time, let's look at ones that are compressed. So this first one here is y equals 0.5 times x plus 2 squared. All right, so a in this case is 0.5, or we can call that 1/2. H is negative 2. I don't see a number over here, so k is 0. So hk is negative 2, 0. There it is. It just was translated left 2 units. Now, do you see the compression? You see that our new parabola is wider or fatter, right? Why is that? Well, typically your parabola, you go over 1, you go up 1 unit. But on this parabola, the new one, we go over 1, we're only going to go up a half. Usually we'll go over 2, we go up 4. But on our parabola here, the new one, we're going to go over 2, and we'll go up half of 4, which is only 2 units. So this one, it's going up half as fast as the original parent graph, which is why it becomes wider or fatter. Okay? How about our next one here? We have y equals negative 0.25 times x minus 1 squared plus 4. So my a value is negative 0.25. I could also call that negative 1/4. I want the fraction. So that's my a value. Since it's negative, we know it reflects over the x-axis, so that's why it's opening down. All right. Our h value is going to be positive 1. So it's positive 1 for h. K value is positive 4. So we expect our vertex to be at 1, 4. There it is. There's the vertex, 1, 4. And this is compressed. So you see how we have a much wider parabola, because you usually go over 1, up 1. We're going to go over 1. We're going to go down a fourth. Right? Usually you go over 2, you go up 4. We're going to go over 2. We're only going to go down 1. Look at that. 1, 2, down only 1 unit. Okay, it's going down 1/4 of the normal rate. All right, last one. Then I'll let you play on some if you need some more with Desmos. So A in this case is, be careful, that's 0.1 or 1/10. So our A value is 1 over 10. All right. Our H value is 6. Our K value is negative 1. So I expect my vertex to be at 6, negative 1. There it is. 6, negative 1. My A value is really close to 0, so I expect it to be extremely compressed. You see how wide this parabola is? Very fat parabola, right? Because it's compressed big time. You're only going up 1/10 the speed at the parent graph. So if this goes up over 1 for this one, it only goes over 1, it always goes up 1/10 or 0.1 units is all it goes up. That's why it's going up very slow. All right. All right, need more examples or do you want to just play with this a little bit? Go to desmos.com and graph them. Put in the y equals x squared first, so you have your parent graph always referenced compared to the parent graph. And then type in your equation. Remember, we want squared, you use this little a to the second key. That'll help you do the squaring part. So type in your equations. Why don't you try to make predictions yourself? Try to predict, where's the vertex going to be? Is it going to open up or open down? Is it going to be stretched or compressed? Then type it in and then see where it's at on the graph. Was your prediction correct? All right, just keep doing these until you got it down. Keep playing with it. Hope this has been helpful.